For this question, we have the following operational amplifier. And for this op-amp circuit shown, we're asked what value must our R2 be in kilo ohms in order to set the voltage gain to 10.2 dB. We're going to assume that the op-amp is ideal and our R1 is equal to 6.3 kilo ohms. And we have other problems that are similar to this, same format, and those are in the playlist in the description. But we're going to be looking at the notes for this. And for this problem, we want to solve for our R2. We are given a few things though. We're given our R1, which is great, and we're also given the voltage gain to 10.2 dB. And this is important because if we look in the notes, there's a section expressing gain in decibels. So we're going to have the voltage gain in decibels, and we know we have voltage gain to 10.2 dB. So what we can do is we can take this equation and say we have our 10.2 equal to the 20 log base 10, and then we have our absolute values of our A, V inside of here. Now all we need to do is raise or divide both sides by 20 first, and then raise both sides with the power of 10 to cancel out with this log. So that means our AV is going to be equal to 10 raised to 10.2 divided by 20. So that's our equation for AV. Now that's not it for what we have to solve for. That's just kind of step one. For step 2, because this isn't our R2, step 2, we're going to look at a very simple equation where we have the ideal op-amp assumptions for our non-inverting amplifier. We know, or for the inverting amplifier. And we know it's inverting is because we have our source voltage connected to the negative input of our op-amp. If it was connected to the positive, it would be non-inverting. So we have our inverting amplifier right here. And then we can look at our assumption right here. This is the equation that we're going to use for nodal analysis. So with this nodal analysis, we are going to have our AV equal to V naught over V input, which is equal to negative R2 over R1. And this is perfect for what we want to find. We're going to be using this negative R2 over R1. Now, we know that this is either equal to our V naught over VI, or I'm sorry, our V naught subscript VI. It's equal to our A subscript V as well. So what we can do is we can take this and plug this in here. So if we go into a calculator, I'm going to use a Symbol Lab for this one. So if we go into a calculator, we have the left side as 10 raised to 10.2 over 20. And then we multiply that by our R1, which is 6.3, and multiply both sides by the negative. The negative in this case does not really matter, and we'll come back to this in a second. So excluding the negative, if we have our 10, and this is really step 3, where we have our 10 raised to 10.2 over 20, and this is being multiplied by our 6.3. I'm omitting the kilo ohms because the actual question is asking us to find it in kilo ohms. So we don't need to continue it over. It is good practice though, so we should do that, but we're just skipping over it for simplicity here. And so with this right here written, we're going to have this, and it's equal to a negative R2. And so our R2 is going to be approximately 20.4, or we can say 20.39 ohms for better accuracy. And the reason why we don't include the negative is because resistors are negative, or not negative. Resistors are never negative. They cannot be negative. The reason why it's a negative is because we have a inverting amplifier. And that is how we would look at this circuit and this problem and anything like it.